Hello, I'm Richard Patterson, and I'd like to welcome you to this video presented by IPC Irwin, featuring these instruments which will measure voltage potential difference. So before choosing a voltmeter, it's important to know the range of voltage potential difference you're going to measure and whether it's normally DC or AC. So these two instruments are DC voltmeters. This one will measure up to 20 volts. And this one will measure up to 2 volts. This one has a resolution of 0.01 volt, and the smaller range has a greater resolution, so you can get down to 0.001 volts resolution there. So if you're buying a class set of these meters, it's important to think about the features, the operating features that make it better for your students to use them. Well, one thing is that the battery can only be accessed using a screwdriver to remove the back case, so that does help with any students who want to go tinkering with the batteries. There's an angled display, a large angled display, 13 millimeters high, that we'll see in close-up in a second. We switch on using the little slide switch there. And the other nice feature is that the ports, the positive and negative ports, are both sides of the meter, which means the leads aren't going to obscure measurements. It's a tough ABS plastic case, and it's got 3 nice rubber feet that keep it steady on the bench. So we'll now connect these into a circuit, and we'll take a close-up of the reading to see how they measure potential difference. So I've switched both meters on now, and I hope you can see that they're ready to be connected to a circuit. And our 20 volt meter is showing you 2 decimal places. Our 2 volt meter has got 3. So we've got a 12 volt lamp connected to this small bench power supply, which is part of the IPC Irwin mobile bench, which you can see in another episode. The scale there is marked off from 2 to 12 volts. And as you'll see in a second, when we connect the meter to it, the meter will give a more accurate measurement of the voltage. These are just rough indications of the output of this unit. We've got the lamp lighting there, we switch on, and at the minute we've got about 2 volts on there. Now, 2 volts is just at the top range of this meter here. So it's important when students are connecting the voltmeter into the circuit, we connect voltmeters in parallel. And we connect the black lead to the side of the circuit that's closest to the negative output of the power supply, which would be this one here. So I'll connect that to there, and I'll connect that one to there. And despite this showing 2, our meter is indicating 1.06 volts. And if we look at the display, we haven't got a negative sign there, which means it's reading a positive voltage. So just to demonstrate, if I swap these 2 leads round, so the positive is now connected to the negative side of the circuit and vice versa with the negative side, you'll now see that we get the same display, but there's a negative sign appearing in the display, which, as far as the meter is concerned, it's recording a negative voltage. I'll restore that back to how it was. And again, we've got 1.826 volts coming out that. Now, if I increase the output from the bench supply, we'll overload this meter as we get beyond 2. The lamp gets brighter, and we've now gone into the overload condition, and it's showing just a solitary vertical 1 there, meaning it can't measure any more. I'll switch off and disconnect the meter, switch it off, and bring in this meter, this more meter, connected in exactly the same way. And the maximum voltage recorded by this instrument is 20 volts DC. So if I switch it on now and put the bench power supply on now, we can see now that this meter can display it. It's 3.994 volts. So if I increase this, we can see that the meter is roughly following the output of the bench power supply. There we are, we'll maximum output from here, 12 volts, the bulb is at its brightest, and we're recording 12.4 volts there. So that's our IPC voltmeter, and in further episodes, we can see how we can record lamps in series and parallel. So we're now going to use these two instruments to measure potential difference or voltage. So I've got a power supply, a bench power supply, a small one, which is part of the IPC mobile bench, which you can see in another episode. If we just look at the front panel, we've got an on-off switch there, a rotary control, which is marked off from 2 to 12. As you'll see when we start using the meters, this is just a rough indication of the output, and you should always use the display on the voltmeter as to the true potential difference we're measuring. The output ports there's a pair of DC outputs, negative and positive, black and red, and the two yellow are providing an AC output there, and the maximum current is 5 amps. We've got a lamp there ready to connect. Always make sure the control is on its lowest because we don't want to burn out the lamp. And if we connect it up to the DC output, we should see that light up. Like so. So that's got roughly 2 volts across it, and if we raise that up to 4 volts, again, the brightness increases. Put it back down to 2, and let's use our first meter, which is maximum of 2 volts. Yeah. Now, I'm going to connect this black lead to the negative port and the red lead to the positive port. So try and get the students to realise we've got negative and positive voltages, and this will indicate a positive voltage if we connect the negative lead to the negative side of the circuit there. That's the lead that's connected to the black of the power supply. Connect this to the positive side there, and there we have plus 1.8 volts, which is a bit lower than the 2 volts there. Okay, let's increase this to 4, and watch what happens to the display. We've now exceeded the maximum voltage this takes, 2 volts, and we've got into an overload condition there with that 1 indicator there. So what I'm going to do is switch that off, disconnect the meter, and bring in the voltmeter with a greater range. Switch that on. And now, if we increase that to roughly 4 volts, this meter is now displaying 3.92. So that's how we can do our very first measurement using the meter connected in parallel for potential difference or voltage. So as an extension, we can give our students sources of potential difference beyond bench power supplies and dry cells. And what we have here is a 2-panel solar cell, which is being powered up from light from the studio lights. So I've got a 20-volt meter here, which I'll switch on. I know in advance that this is the right range for these solar panels. And if we connect one solar panel up to the meter, I'm not too bothered about polarity with this one. We're now getting about 2.8 volts from the single solar panel. If we disconnect the meter and connect the 2 solar panels in series, and this is just like connecting 2 dry cells up, we should get roughly double the voltage, like so. We're going to get about 5.75. And just to demonstrate that these solar panels are working, they're picking up light from the studio lights. If we cover those with your hand, we can see that the output drops like so.